Updates for you tonight. Crews are responding right now to a new fire start tonight in Yellowstone National Park. The ash fire is located in the southwest corner of the park.
The United States Geological Survey, USGS, has issued a red alert in response to the unexpected and fast expansion of the Yellowstone caldera's magma chamber, a revelation that has sent shockwaves through the scientific community and prompted increased monitoring measures around the region. The red signal, which is normally designated for imminent volcanic activity or high geologic instability, emphasizes the gravity of the situation unfolding beneath one of the world's most closely studied supervolcanoes. Before we begin, please hit the like and subscribe buttons for future updates. Yellowstone has long been the subject of considerable geological examination due to its reputation as a supervolcano with a million-year history of eruptions. Its last major eruption, approximately 640,000 years ago, created a caldera nearly 45 miles wide and changed the terrain of what is now Yellowstone National Park. Though much of its activity in the modern era has been relatively moderate, as evidenced by earthquakes, hydrothermal activity, and sluggish ground uplift, the most recent data from satellite imaging, ground sensors, and deep seismic monitoring present a different picture. Something major is happening deep within the Earth's crust. The magma chamber beneath Yellowstone, which was thought to be slowly inflating over decades, is now showing symptoms of fast expansion. This discovery followed months of unusual seismic activity and variations in ground deformation patterns that differed significantly from historical averages. Instruments that monitor ground uplift began indicating faster than normal swelling across the park, particularly in the Norris Geyser Basin and the caldera's western rim. What began as a steady incline became a significant spike, forcing scientists to investigate the explanation. Geophysical imaging indicated that the magma chamber, a massive store of molten rock several miles beneath the surface, was accumulating magma at a rapid pace. This accumulation appears to be caused by an abnormally active period in the Earth's mantle, in which hot, buoyant rock pushes upward, filling the chamber with new material faster than it can cool or disperse. This dynamic inflow of molten rock has resulted in increased pressure, causing the surrounding rock layers to bulge and split. One of the most worrying symptoms has been a significant increase in harmonic tremors, which are low-frequency rhythmic earthquakes associated with magma flow. These tremors have been more regular and strong in recent weeks, indicating that magma is not only rising, but also moving through the system in complicated and possibly dangerous ways. Scientists have observed swarms of earthquakes, sometimes numbering in the hundreds over a period of days, when molten rock makes its way through the crust. Unlike normal earthquakes, which are triggered by tectonic plates colliding, these swarms are frequently shallow and localized, indicating that the activity is anchored in magmatic movement. This type of seismic behavior is comparable with trends found at other volcanoes prior to eruptions, supporting the USGS's decision to raise the warning level. The issuance of a red alert is not done lightly. It is necessary to provide clear evidence that conditions are rapidly changing in a way that may endanger public safety. Yellowstone has far-reaching repercussions. A red alert does not ensure an impending eruption, but it does indicate that the system is behaving in a way that requires rapid and constant monitoring. Every tiny change in seismicity, earth deformation, or gas emission is now critically important. Hydrothermal features around the park have responded to the underlying changes. Geysers have erupted more often, bringing previously dormant features to life. Steam vents, also known as fumaroles, have become more active, producing higher levels of sulfur dioxide and carbon dioxide, gases that frequently accompany magma near the surface. These changes in surface activity provide more indication that the magmatic system is becoming more energized. Yellowstone functions geologically as a pressure cooker enclosed beneath a thick crust. The supervolcano is unique in that its magma chamber is quite shallow, only a few kilometers beneath the surface in some parts. This close proximity to the surface raises the likelihood of magma breaching the crust if pressure continues to develop. The magma's silica-rich makeup makes it extremely explosive due to its high viscosity, which stores gases before rapidly releasing them. To understand the ramifications of this fast expansion, we must first examine the nature of supervolcanoes. Unlike ordinary stratovolcanoes like Mount St. Helens and Mount Fuji, supervolcanoes erupt with massive explosive outbursts capable of blanketing continents in ash. A full-fledged Yellowstone eruption, while still considered unlikely in the immediate future, would be orders of magnitude more destructive than anything seen in contemporary times. It would have an impact on global climate, impair agricultural production, and result in significant human displacement. Even without an eruption, the ongoing activity poses serious threats. The magma chamber's development could cause hydrothermal explosions, which are localized but powerful blasts of steam and gas that can kill anyone nearby. Ground collapses or sinkholes may arise as the Earth's structure is stressed, and the risk of poisonous gas leaks is always there. Furthermore, earthquake swarms can cause landslides and destroy infrastructure, especially in regions like the Yellowstone Plateau, where the terrain is inherently unstable. The Red Alert also mandates a review of the region's risk management procedures. Emergency protocols are being reviewed, evacuation plans are being amended, and communication networks are being tested to ensure their speedy deployment. Park officials are working with federal agencies to guarantee that tourists and neighboring communities are notified immediately if situations worsen. Scientific teams have increased the frequency with which they conduct fieldwork, utilizing everything from drones to mobile seismic arrays to monitor the growing situation. Technological advancements in the last decade have enabled experts to look deeper into Yellowstone's inner workings than ever before. GPS stations installed around the park now provide real-time updates on ground deformation, while satellite-based INSAR interferometric synthetic aperture radar devices provide an aerial picture of surface changes over time. These techniques, when combined with deep borehole sensors and gas monitoring stations, provide a multi-layered image of the system's health. Despite these efforts, Yellowstone remains a completely unpredictable giant. Geological processes occur on such timescales that even the finest models can only provide probability rather than certainty. What makes this current phase so disturbing is that it deviates from established norms. Yellowstone has always experienced periods of peace and disturbance, but the magma chamber has never expanded at this rate in the age of contemporary observation. The scientific community is now faced with the challenge of appropriately interpreting the signals. A super eruption is the worst-case scenario, but there are numerous more possibilities. Following the surge, the chamber could stabilize, gradually releasing pressure via modest eruptions or enhanced hydrothermal activity. Alternatively, it may continue to swell, resulting in modest eruptions that, while not catastrophic, could have major regional implications. The unknown makes preparation all the more important. What is evident is that Yellowstone has entered a new period of activity, one that requires close observation and a deep respect for the enormous forces operating beneath the surface. The Red Alert acts as both a warning and a reminder of our dynamic world. Yellowstone's picturesque landscapes, geysers, hot springs, and sweeping valleys conceal a volatile geological engine capable of rewriting entire ecosystems in an instant. While scientists work feverishly to decode the signals and model potential outcomes, nature follows its own path, unconcerned about human deadlines. The magma chamber's fast development demonstrates that the supervolcano is far from inactive. In truth, it is very much alive, pulsing with energy and changing its interior architecture with each passing day. It is unclear if this current phase will result in an eruption or a period of unsettling stillness. For the time being, however, the Red Alert represents both a scientific milestone and a cultural dilemma. Yellowstone's Red Alert has drawn global attention to the turbulent subsurface dynamics. Scientists have now shown that the magma chamber is stratified, with hotter, less dense magma moving into cooler, more viscous zones, resulting in volatile gas release and increased internal pressure. Isotope data indicate a rise in deep magmatic gases, which supports indicators of fast expansion. Surface alterations are emerging. Changed geyser activity, reactivated springs, and microfractures far outside the known chamber indicate that stress is extending into previously stable places. This raises fears that Yellowstone's influence goes beyond the present hazard zones. Experts are divided. Some regard this as part of a centuries-long geological pulse, while others worry that it could foreshadow a greater event. Even in the absence of an eruption, delays may occur in air transport, water supplies, and agriculture. Emergency systems are being updated to facilitate speedy evacuations, while misinformation on the internet drives public worry. Researchers are also investigating fault reactivation, ice melt threats, and environmental changes that may reveal new extremophile life. Yellowstone is a restless giant, The red alert is not the end. It is a warning. Every tremor serves as a reminder of nature's unpredictable nature and the importance of planning ahead of time. If you enjoyed this video, please like, subscribe, and share your comments below. Natural cycle or severe threat ahead?